Good afternoon, one and all. Once again, I welcome you all for the session 2 of Day 6 GATE training program organized by Department of Civil Engineering, VPCE, Mysuru. For the second session of 6th day, we have with us Professor Anjan B K, who is working as an assistant professor in the Department of Civil Engineering, will be discussing the geomatics engineering in this session. Professor Anjan B K has been working as an assistant professor in the Department of Civil Engineering, VVCE, from last 7 years. He completed his diploma in civil engineering from CPC Polytechnic, Mysuru in 2009, undergraduation in Government Engineering College, Chamarajanagar in 2012, and did his master's in structural engineering from VTU Regional Center, Mysuru in 2014. He has guided one MTech student and he has published many technical papers in reputed journals and conferences. His areas of interest are seismic analysis of structure, prestressed concrete, lightweight concrete, and geomatics engineering. Without further delay, I hand over the session to Professor Anjan B K. On behalf of department and my personal behalf of, I welcome you for the session 2, sir. Over to you, sir. Anjan sir, you are muted.
Thank you, Professor Arjun. And I welcome all the participants for this GATE 2022 session on geomatics. And we're in the geomatics engineering, today we'll be discussing on some of the important basic ideas behind geomatics engineering, which is basically called as surveying. And we'll be focusing on some of the some of the questions which are regularly asked in the subject. So the syllabus is like this. We have principles of surveying and errors and their adjustment in the measurements, and we have maps. For that we have calculation for scale, and we have problems on distance and angles, and leveling and trigonometric leveling, traversing and triangulation survey, and about curves. And about the second part of this geomatics, it's already been covered by my colleague, Professor Girish P. So he has covered this photogeometry part, whereas I will be covering the first portion of the syllabus, that is completely on the principles of surveying up to curves. So to start with, of course, earlier we are calling it as surveying. Now in the modern era, we call the surveying as geomatics, where geo means the earth and the matics means measurements. So basically what we do in surveying is measurements of the details on the land. So that is the reason why we have named, now the name for surveying is given as geomatics engineering. The application of this surveying is geomatics engineering. And what is surveying? Surveying is defined as the science of making measurements of the earth, especially the surface of the earth. It is not that we will be only measuring, we are only interested in the surface of the earth, but we will be also doing surveying on the water and also on the astronomical surveying. So all these are part of the geomatics. And another way, the definition of surveying is this is being carried out by finding the spatial location, that is relative or absolute, of points on or near the surface of the earth. So what is the meaning of this relative or absolute means? Relative means you have, see, our survey work starts with some points or the stations. So those stations, if we know the background, in general words, if I want to say, if we know the background of that surface, if we know the features of the surface, then we call relative station. When it will become absolute means if we have uh, the we have to consider some control points. From the control points we are finding out some intermediate points, so those intermediate points we can term it as or some new points which are not having any features. Basically we don't know anything about those points, so those are called absolute points. So that is the main objective in surveying, that finding out the features of the points. So primarily in surveying we have two divisions, or you can say two types. One is we call it as geodetic surveying, and the other one is called as plane surveying. So in geodetic surveying, what we will do is the curvature of the surface. You know that the earth is having curvature, so that is it is spheroidal. So which means the earth is not flat. So all these details, whatever we are taking, all the measurements, whatever we take, will be having some errors, and they need some corrections. So that is the importance how we need to minimize the error, so that our actual value or the true value, so that the measure value will be matching up with the true value. See, in surveying we will not get the true value. It's not possible. There will be always some errors, but as much as possible we will try to make sure that the measured value will be same as that of the true value. So in geodetic surveying, what we will do is we will consider the curvature of the earth, whereas in plane surveying we will be not considering the curvature of the earth. That is, the spheroidal shape of the earth will be neglected in the plane surveying. But in when you want to have a better accuracy, then geodetic surveying is the one which we prefer. And for small and for not so important work, we will be referring or we will be doing plane surveying. So let us have some a difference between this plane surveying and geodetic surveying. And in that, in the plane surveying, the earth surface is considered as plane surface, means flat. Whereas in geodetic surveying, the earth surface we consider it is it's a curved one. And the curvature of the earth is ignored. Of course, in the plane surveying, the curvature of the earth is ignored, but in the geodetic surveying, curvature of the earth will be taken into consideration. And any 2 points or any two stations, if you connect in the surveying, so it is believed that it will be straight line. Any 2 points or any two station you connect with the line, so it is believed it's a straight line in plane surveying. Whereas in geodetic surveying, it is not a straight line. It is having some spherical shape. The triangle formed by any 3 points is considered as plane in plane surveying, whereas in geodetic surveying, it is spherical. The angles of triangles are considered as plane angles. With respect to angles, if you are measuring the angle in plane surveying, we call it as plane angles, whereas we will be only concentrating on two-dimensional views. Whereas in geodetic surveying, we will be considering spherical angles. That means we will be considering three-dimensional view of the earth. And plane surveying is adapted for small area where it will be lesser than 250 kilometers square. If the area of survey boundary we are doing is less than 250 kilometers square, means we'll be uh, taking small areas. And if the area is more than 250 kilometers square, then we will be considering it using geodetic surveying. So basically, it's very easy that if you are doing for a small area and for less accurate work, we normally use plane surveying. If you want accuracy, should be most important thing, and also the area under which you will be doing the survey work is more, then we will go for geodetic surveying, wherein we will be considering the curvature of the earth as one of the important feature in geodetic surveying. And coming to the next important thing in surveying is fundamental principles. So there are two fundamental principles are there in surveying. One is always we have to work from whole to part. So always we need to work from whole to part, which means, say for example, we have a 2 points needs to be measured, say A and B. And this is the entire work. The objective of this work is to measure the distance between these 2 points. But we will be using certain instruments. Those instruments have some limitations, like we may be using chain or we may be using tape. So if you are using tape, a tape maybe we may be having tape of 30 meter length or maybe 50 meter length. But the actual distance from A to B is more than that. Assume that it is 100 meters. So this is the whole work. This 100 meter we cannot measure it with a single stretch with using the tape which is of 30 meter length. So then what we will do is we will divide this whole area into smaller parts. We will find out some intermediate points C and D in such a way that C and D will be in line with our control points. Which are control points? A and B are called as control points, or we can name it as reference points. So A and B as our reference points, we will identify C and D intermediate points, and so that we will divide this entire work into smaller parts. Now our work, now we can measure the distance from A to C. We can call it as L1. Measure the distance from C to D, call it as L2. Measure distance from D to B, call it as L3. So add all the lengths, smaller lengths, and you will get the entire length, which is what our objective is. So this is the principle, first principle, that is working from whole to part. And coming to the next principle is, see, our surveying work is always focusing on points. In other words, stations. The stations, as I already told you. So in order to locate any new station, we need to have some two measurements, means we need to have two reference points. Of course, before we start our survey work, we need to have some known points, some known stations, then only we can start our work. Otherwise we need to assume certain details, then we can carry out the work. So basically, if you have 2 points and you want the third point is our new point, then we need to have, for example, we have 2 points A and B. Now we need to find a new point C. So there may be uh, different ways to find the new station, but the second principle talks about, if you want to find a new station, then you should have two known points. So which are known control points? A and B are known. So if you connect those 2 points, you get a reference line. And in this reference line, AB line, if you want to find a new point, say C, so there is some two dimensions, two measurements you must have. So what are those two measurements? So first one, if you have the distance, like if you have the distance AC and distance BC, we can find the new point. That means if you have the distance of line AC and BC, we will find the new point. This is one way. Second one, if you have the distance of any line, the distance of that line plus an angle. Like if you have the distance AC known, if you know the distance AC, and if you know the angle at which this line AC is from the reference line. So two measurements. One is one distance, AC distance, and angle A. That is angle BAC. If you know the angle, then we can find the new point C. Like that, if you know two angles, that is the angle from at B and angle at A. Say angle at B is beta. So if you know theta and beta, two angles, and if these lines, if you plot the line from station A and station B with the angles, wherever these line intersect, so the intersection of the line will give us the new point or the new station. So like that, a simple way of doing is, if you have 2 points if you have 2 points, so you should know some of the properties, features, like we have two reference points. I have to find a new point. So for example, I will say we have to have a perpendicular line to this AB. So erect a perpendicular line. You know the feature, this is right angle, now it should be 90 degree, and you should know what is the distance from this reference line. So what is the distance? If you know the distance, we will get a new point. So this is the second principle. Second principle is, if you want to find a new point, we should have the control points. From that control points, we should know two measurements, at least two measurements. It may be a distance or it may be an angle. So that is the principle, two principles in surveying, fundamental principles in surveying. Now coming to next part is scales. So if you are collecting the details, usually we measure the distances in meters, but when you are drawing, when you're putting it into a drawing, so we will normally minimize it into smaller dimensions. So that is what is mean by scale. So the actual distance between A and B is 20 meters, but we cannot measure that, we cannot draw that 20-meter line on a paper, on a sheet of paper. So there we need to use this scale as one of the conversion factor for us to prepare a map. So this is what the importance of scale. And in that, we have two types of scales we use, and most of the time we'll be representing that with a representative fraction, which is in an engineer scale, we will be representing 1 centimeter will be 40 meter. Normally we use 1 is to 40. What is the meaning of that? 1 centimeter on the drawing is equal to 40 meter on the ground. Okay, so this is the importance in scale. Whereas in another way, if you want to represent, we use a representative fractions, wherein both these numbers will be of same unit. Whereas if you see in engineer scale, this 1 is in centimeter and 40 is in meters. Whereas in representative fraction, we must use this scale with the same units, which means if 1 is centimeter, then 4000 is also 4000 centimeters. So we'll be using the representative fraction in both of the values will be in same unit. So that is why in most of the maps, when we see, the maps will be represented with the scale representative fraction, not with the our engineer scale. Normally we use engineer scale for a smaller dimensions of work, like doors and windows. By whereas if you want to prepare a map, we will go with a representative fraction. So next is errors. Of course, if you have any measurement, there will be error. It may be an error in converting the measured length and putting that into a drawing, that is at the stage of applying the scale, or it may be at the time of measurement also, or it may be due to instruments. The error may be due to instruments, or the errors may be of natural errors like climatic changes, or sometimes errors will be personal errors will also be there. Personal errors will be like, uh, you have measured say 10.5 meter distance, but you record that as 1.05 meter distance. So this is personal error. So understanding wise, see, you measured correctly, but you are recording it wrongly. So that is called personal error. So now if you consider here the example given for the error for scale. We have a plan which is drawn to a scale of 1 is to 200, and the length measured with a scale of representative fraction is 1 is to 250, which means, see, we have assume that we are measuring some length. So here the measured length is some measured length, we measure say 250 meter is the measured length. And in order to find the correct length, what we have to do is we have to use the representative fraction of the wrong scale. The wrong scale is here 1 is to 250, which is the wrong scale. and RF, representative fraction of the correct scale. So what is the correct scale, which is actually, see, we have assumed 1:250 is the scale for drawing a map. But what we did at the end, we used 1:200. We end up with taking 1:200 as a scale to plot a map. So now, actually, the on the map, because ultimately anyone will be seeing is what is there in the map. In the map, we have used 1:200. This is the correct scale now. But actually, what we have started with an assumption, calculation wise, we calculated it 1:250. For that, we did. So therefore, whenever you have to calculate the mistakes, if you want to avoid this type of mistake, so in order to find the correct length, we use this formula. That is representation fraction of wrong scale by representative fraction of the correct length into, or you can say correct scale into measured length. And similarly, if you have you want to calculate the correct area, then in order to calculate the correct area, same formula, but you have to just square it. Representative fraction of the wrong scale by representative fraction of correct length into the measured length or the measured area here. Okay, so because you are calculating the correct area. So here is a one question from asked in, a, in some of this type of questions will be asked in the gate. So find the representative fraction, that is 1 by 2500 means that for the scale of 1 centimeter is equal to. So here they're asking us, this one is having unit 1 centimeter. Just now I told you that in representative fraction, this 1 by 2500 represents means the having this value are of same units, which means they are mentioning this one is centimeter, that means it is 2500 centimeters. So if this is 2500 centimeters, then what is the actual length which is on the ground? See, this 1 centimeter is on the map, so this 2500 is the length measured on the ground. So among this, which is the length, that is, because here they are given it in meters and kilometers, so you need to convert this into meters. So what is the conversion? 100 centimeter is nothing but 1 meter. So if 100 centimeter is 1 meter, then what about 2500? That is 2500 divided by 100. If you do, we get 25 meters. So if you have the answer 25, then the correct answer here is option C. Option C, that is 25 meter is the length. So for example, if this 25 meter is not given in this list, then you have to convert this into kilometers. There you will get that answer will be available. Or they may give it in centimeters, or they may give it in millimeters, okay, or they may give it in kilometers, like that. But in representative fraction, both the values will be, the denominator value and the numerator value both will be in same unit. So moving on to next question, that is, the plan of a map was photocopied to a reduced size such that a line originally 100 millimeter measures 95 mm. So originally we have drawn a line which is earlier 100 mm. Now if you measure it on that map, it is measuring it as, or it is showing it as 95 mm. Means the map has shrinked. The original scale of the plan was 1:1200. Then the revised scale. So if we have the original scale, which is 1:1200, at that time the original length is 100 mm. Now the line is measuring, if we measure the same points and those 2 points are measuring as 95 meter, then they are asking us to find what is the scale of that new measurements after, because of the shrink in the map. So therefore the original length is 100 mm and the shrink length is 95 mm. So the ratio we will find out, the shrinkage ratio is nothing but L dash by L, that is the amount of length which is shrink by the original length. So we have taken that in centimeters, because in the representative fraction these values will be represented in centimeters. So therefore, the whatever the scale which has shrunk will be given by shrunk scale will be original scale into shrunk. So the original scale is 1 by 1200, and the value shrunk ratio is 9.5 by 10. So on solving we get, you have to calculate it for the 1 centimeter length, it will be shrunk to 1263. So which means originally it was 1200 scale, because the now the measurement has reduced, now the scale has got increased, that is for 1 is to 1263. So therefore the answer for this is B. So like that they may change some numerical values, but the solving the problem is very simple. You should remember this formulas in order to get the actual or the shrunk scale, or they may give the shrunk scale and they will ask you to find the original scale, like that questions. And moving on to the next part is the errors. We have just seen errors in scale. Now we will concentrate on errors in measurements, like in chain or in the measurements using the tape. So there are, for example, we are using a chain which is incorrect. Normally the standard length of this chain is some climatic condition. Now the chain length is not measuring exactly the standard length, which is 20 meter. So there may be two cases. That is, a chain if the chain is too long, that means the measured distance will be normally less. Okay, if the chain length is say 20.5 meter, then the measured length will be 20 meter. So we believe that because the chain is too long, that means the measured distance will be automatically, because we believe that because the change has become too long, but what we will consider is we consider still now the chain is having a length of 20 meter, the standard length. So therefore what happens, whatever the measured length we get will be of lesser amount. So therefore, the error will be negative. If the chain is long, error will be negative, the correction will be positive. Similarly, vice versa for chain having too short. If the chain is too short, which means 19.5 meters, so we assume that, see, actual length of the chain is 19.5 now, but the as per standard what we believe 20 meters. So we have a 0.5 meters of shortage. So that 0.5 meter of length will become an additive error. It will be positive. It will be, as the number of chains length we will be increasing, so it will become positive. So therefore the correction will be opposite to that, that is negative error. So there will be a problem on this normally. So they'll be asking you to find what is the error in the, they'll be asking you to find the what is the correct length or what is the error in the measured length. So we will be solving some of those problems in the later stage. And in the tape, that is regarding is chain. So that is, you have L dash, the measured length, minus L, which is the actual length, divided by L into L dash. This will give you the actual correct length of the line. Similarly, if you are using tape, the tape may be made up of different materials, maybe a fiber, maybe a metallic. So depends on that. The temperature also affects the instrument, that is tape. So that the temperature may be, so normally for laboratory condition, for 27 degrees centigrade only we need to use the tape. For that only the tapes will be manufactured. But normally in the working condition we cannot satisfy, we cannot get 27 degrees centigrade always. So therefore the correction, if it is more the temperature, you know that the tape will enlarge, and if it is lesser, means temperature is cooler, then uh, it will be shrinked, or it will be decreasing the length, correct? So therefore that is one correction. Next is correction for pull, because when you are using a tape you may pull from the either end, due to that also this tape may get stretched. and correction for sag, which is instead of measuring the distance with a straight path, if you give some loop, then it will be hanging. The tape will be hanging, and in order to, if you are holding the tape in that way, then you will end up with, of course, you will end up with normal, whatever may be the actual length, you will end up with a maximum length than the actual one. So therefore, the correction here is always negative. For correction for pull is always positive because you are stretching and it will be positive, whereas in sag it will be, correction will be negative but the error is positive. See, to confuse you in the gate, what they will ask is, sometimes they will ask what to find the error, sometimes they will ask to find the corrections. So if they ask you to find the error, then it is the opposite signs you have to take, whatever is listed here. So I have listed here the correction signs. So if they are asking us to find the errors, then you have to change the sign to opposite side. That is, correction for sag is negative, the error for sag will be positive. Similarly, correction for slope is negative. So some of the formulas are there, so I'm not going to do the derivation. And these are the formulas which will be used to find the, apply the corrections for the temperature, where alpha is uh, the Tm is the temperature, standard temperature, T naught or To is the temperature at the time of measurement, L is the measured length, and alpha is the coefficient of the thermal efficiency of the tape material. Similarly, corrections for pull is given by P minus Ps by Ae into L, because here we will be considering, we need to consider the cross-sectional area of the tape. So how much it will be affected, the cross-sectional area depends on the cross-sectional area of the tape. So it will be varying. So and next, for correction for sag is given by, it is always, I told you it will be negative, so that's why in the formula it is negative, the correction. So correction for sag is W square L by 24 P square. So this W is the unit weight of the tape. Because of that unit weight of the tape, sometimes the tape will deviate. So that is the unit they are given. And we have slope. For slope, the correction is negative, which is given by h square by 2l. So they will give you the details or the data for these values, and they will ask us to find in the gate what is the correction due to temperature, what is the correction due to pull. So the details will be given. Similarly, some of the questions will be asked on tension, normal tension. That is, we'll be having we are applying the tension on either side, then we will be comparing that with the sag. See, sometimes what we need to do is, in order to overcome the correction, the error due to sag, sometimes what we will do is we'll apply some force. So what is this normal tension means? See, the tape has sulfate, its own sulfate. Due to that, it has sag. In order to overcome, what we will do, we will apply some force here at these handles. So this is nothing but you're pulling, you're applying a force in order to make this a tape which is in a sag shape, to make it into a straight one. Correct? So it should be equal. If you stress it, if you pull it, if you apply more force, again it's going to lead to a correction for pull. If you don't pull required, how much is required, then it will be ending, we will be ending up with this sag. So therefore, by equating these two, you have to concentrate on these two equations, where amount of pull, whatever the force applied, should be equal to avoid, it should be sufficient to avoid this sag, the sag portion of the tape. So that is called as the normal tension. The normal tension required to minimize the correction for sag as 0. To make the tape straight, what is the minimum amount of force we need to apply? That is what we called as normal tension. What is the force we need to apply so that to nullify the corrections for sag? That is called normal tension. So it is basically these two equations which are used here, in order to there we will be finding P, force P here, equating in this equation where you'll be finding they'll be asking a question on finding the P force. What is the force you need to apply in order to avoid the correction for sag? So here are some of the questions which are asked in the GATE format. A 30-meter metric chain is found to be zero point 0.1 meter too short throughout the measurement. If the the distance measured is recorded as 300 meters, then the actual distance measured will be. So here measured length, what they have measured is they have measured 300 meters, and what they are giving is they are using 30-meter chain, and that chain or the chain is having zero point 0.1 meter too short. So the chain is 0.1 meter too short. So therefore, the as per the standard length of the tape is of course is 30 meter. Now what will be the actual length? Now the actual length will be, because it is too short, which means from the 30 meter we need to deduct that 0.1 meter. Now actually we are using a 30-meter tape, but the actual length of the chain, sorry, so it's chain, the actual length of the chain will be 29.9 meters. So what we were measuring, but we have measured a 300-meter length. But actually it's why we are getting 300 meters, but we are taken we have measured 10 times. If you have measured 10 times, 30 into 10 you get 300, but that chain is zero point 0.1 meter too short. So therefore the actual length will become 29.9. So if you multiply this 29.9 into 10, you get the answers for this. Or otherwise what you can do is actual distance. This is the actual length of the chain. So one chain length is equal to 29.9. Then what is the actual length? Actual length will be is equal to, that is, we have chain length L dash, that is actual length, divided by the standard length which is 30 and the measured length. So the L dash by L into measured length. So if we do this, we will be getting what is the actual length. So therefore the actual length will be, so therefore the actual length, if you calculate 29.9 divided by 299 meters, which is nothing but which is option C. So 299 meters is the answer. For example, if for the same question, they ask this with 0.1 meter too long instead of too short. If they make it as too long, so then our actual length of the chain will be, instead of 30 meter, it will become 30.1. So therefore our actual length L dash will become, instead of it becomes 30, it will be, we'll be considering it as 30.1. So this value which is in the numerator will be replaced by 30.1, and you will get accordingly the answer. It will be 301. So therefore to confuse you, they will give both the answers. So you should remember the word, if the chain is too short, in order to calculate the actual length of the chain, if it is too short, deduct that length. If it is too long, add the length. Simple. Next, a tape is 100 meter is suspended between the ends under a pull of 200 Newton. Now the weight of the tape is 30 Newton. The correction for sag and the correct distance between the tape end is. So they have given what is the amount of pull applied, and what is the self weight of the tape, and they are also mentioning that it is a tape of 100 meter length. Now what will be this sag which will happen due to its self weight? what is the amount of that sag, and for that what is the correction. So if you know what is the error due to sag, then we can automatically find the correction. Similarly, what is the correct length of that line. So what you have to do, we have to first concentrate on sag. Just now we saw what is the formula for correction for sag. Correction for sag is W square L by 24 P square. So that means what is W? W means self weight of the tape. In this case, the self weight of the tape is given as 30 Newton. So 30 Newton, that is 30 square into L. L is tape length, which is 100 meters, divided by 24 into P. P is nothing but pull or the force. In this case, the force applied is 200 Newton. So that is P square, 200 square. So if we do the calculation, we get what is the correction for sag. So by solving this, we get the correction for the sag will be equal to 0.094 meters. So now in the option, we have option B and option C is 0.094. If you have only one, you can select directly that one, because in this they have given two options are having same values, 0.094, 0.094. So now we need to calculate what is the actual correct distance between the two end because of this error. So now this is the correction needed for sag. So what is the correction for sag is always negative. So therefore the correct length will be 100 minus correction. The correction is due to sagging. So the sag is always, you need to apply a negative correction, that is 0.094. So after that will give you the actual correct length between the actual length of the tape, in other words. So instead of 100 meters, it will be now measuring. So you can say that it is the wrong answer. It will be not 100, because you are deducting 100 minus 0.4 means it will be 99.906 meters. So the answer is B. That is, so if you have, find out the correction for sag, which is 0.094 meters. Apply that correction for the tape length, which is 100 meters. So the correction is negative for the sag, so therefore the answer is B. And similarly, they may ask the questions with a different lengths, two conditions. Okay, so that is two conditions with two conditions where different types of tape having different unit weight. So there also you need to do them separately, and you have to work out the answer for that questions. And next, moving on to the compass surveying, where we will be measuring the bearings, in which of course we use uh, two systems to measure the bearings. And in the compass, the main important thing is our reference line. See, the reference line in some compass is north and south. Showing you the north direction. So we have two systems. One is called as whole circle bearing system, and the other one is called as quadrantal bearing system. So what is whole circle bearing system? Whole circle bearing system is like our analog phone. In earlier days, we'll be having the phone which we'll be dialing those numbers, and the buttons will be in this far. If you dial this and again this will come back to its same position. Like that, in whole circle bearing, always we start with north is 0 degree. If you have any line in any quadrants, the first quadrant, second, third quadrant, we have 4 quadrants in this. A line may lie in any of these quadrants. Accordingly, we will be measuring the bearing. In whole circle bearing, if your line is in the second quadrant, it doesn't matter where it is, always the bearing will be measured with respect to north. That is what called as whole circle bearing. And in this, the marking of the readings will be marked from 0 degree to 360 degree. East will be 90 degree, south will be 180 degree, and west will be 270 degree. Whereas in quadrant bearing system, each of this name itself is suggesting, sometimes this quadrantal bearing is also called as reduced bearing system. system, reduced bearing system. So in this, the quadrants will be divided into 90 degrees each. 90 degrees each. So each of the quadrant will be divided into 90 degrees. In the quadrant bearing system, we measure between two directions. Say for example, we have this line OB, then we measure the angle. We will be writing that in terms of direction: north, theta, east. Whatever may be the angle with respect to north or with respect to south only we will be measuring. So that is quadrant bearing system. So in our compass, there will be having two types of compass: prismatic compass and surveyor compass. Most of the time, when we use prismatic compass, because in the prismatic compass, the system used is whole circle bearing system. The whole circle bearing system is what used in prismatic compass. If they use surveyor compass is used, they don't ask in the question that whole circle bearing system or quadrant system. Instead of that, to confuse, prismatic compass is used, surveyor compass is used, which means if they use prismatic compass means the system used there is whole circle bearing system. So now there will be some conversions and all, so I'm not going to that basic thing, the conversion from whole circle bearing to a quadrant bearing system. There are some important questions we need to discuss in compass, like this is the one: magnetic declination. So the magnetic declination means, you know that we will be using a compass which is made of magnet, where you know the magnet will get attracted to the iron. So when there is a iron or the steel material which is next to our compass place location, then what happens is, whatever the bearing measured, whatever the bearings we are measuring, we will not get the same bearings. We will end up with getting some error. So that is due to the presence of the iron which is next to our compass. So here we call that the declination. So we have two important terms we need to understand before we understand this magnetic declination. One is, for the earth we have true north. See, this is true north for our planet. Wherever we are measuring the distance, the true north line, the reference line will be fixed. But because we are using the instrument which is using magnet, the magnet may deviate. So the magnet may deviate and it may show its own north. So it is not possible that every time we get the north shown by the magnetic needle will be same as the true north. So true north will be always at the northern and southern pole, but the magnetic north will vary. Say for example, we have this and we are doing the surveying in India somewhere here, and we have placed the our equator is somewhere here, okay, or you assume that now we are doing some work here, and north place here. When you're having compass, then compass will be showing you the magnetic north according to its position. But actually the true north you will get only when you do surveying on the equator, when you place your instrument there. It's not possible. So therefore there will be some error. So the error will be, the error between the true north and the magnetic north is called as declination. So there may be two types. The magnetic north may be towards right side of the true north, or it may be on the left side of the true north. So there, for that we called as eastern declination and western declination. Because to the north, if it is swinging towards right, it is called eastern declination, and if it is swinging towards the left, then we call it as western declination. And normally for eastern declination, we take positive sign. It is positive because it is moving towards east. If it is declining towards the west, then we normally consider it as negative. So this is the basic understanding of the magnetic declination. Now we will see some of the problems on bearings, where some of the simple questions will be like this: if the fore bearing of a line of AB is 35 degree and the line BC is 15 degree, then calculate the angle. Then calculate the included angle. Then you need to first understand, here they have not mentioned they have just given the degrees. That means they have not mentioned the directions, north, east, something like that. That means it is whole circle bearing. So you draw the pictures. Always draw the picture, especially in compass. That will easily we can solve the problem without wasting our time. So here you see from A to B, the line is measured with 35 degree, that is given, and line BC, the next line BC is 15 degree. So which means BC line, if you run, it will go like this, because this is only 15 degrees BC line. So they are asking us to find the included angle. So now we may have confusion. Okay, this is A, this is B, and this is C. So they are asking us to find the included angle. Now, which is included angle? Is this is included angle, or the other side? This is the included angle. So which is the included angle? So that is that type of, that is the mistake what we normally do. So if you take this side, you will get some reading. If you get this side, you will get some reading. Now assume that you get both the answers available here in the list. For example, in this case, let us calculate. In order to calculate the angle here, we need to know what is the back bearing. So we need to calculate the back bearing. So let us calculate the back bearing of line AB. So that is, the back bearing of line AB will be equal to, so in order to get the back bearing, 180 degree back bearing of that line. If the measured forebearing is less than 180 degree, then we need to add 180 degree to get the back bearing. So this principle we should know. So this is the basic fundamental principle in the compass, where the forebearing and back bearing difference is exactly 180 degree. So therefore the back bearing is 115 degree. So now what is this? So now we have this bearing from here to here, it is 215 degrees. 215 degrees. And we have the bearing of the next line, this one as 15 degrees. So in order to calculate the angle, if we deduct 215 degrees minus 15, because if you deduct 215 degrees minus 15, what we will get is, we will get the included angle. So this angle we get. So this angle is how we will get in this entire area. If this is the included angle, so in this 215, if we deduct the 15 degrees, 215 degree minus 15, which is 200 degrees. Now the 200 degree answer is not at all available here. They have given 20, but they have not given 200 degree. So which means this is not the side, or this is not the angle they are asking. They are asking us the other opposite side now. So this is the angle they are asking. This is the included angle they are asking. So then if you have that answer, you will easily select that option. But now it is not coming. Now you need to calculate the other side. So how to calculate that? It will be calculated that angle of the other side, which will be 360 degree whole circle bearing. From the whole circle bearing, if we deduct 215 degrees, what we get is, so I will just write the picture once again. I will clear. See, the back bearing is clear, 215. So what we are now interested in is, we know that we need to calculate this angle. We need to calculate this particular angle, A, B, C. So now we know what is the back bearing. This back bearing is 215 degrees. And we also know what is the bearing of next line. This is 15 degrees. So we need to calculate this included angle here. So that is 360 degree minus 215. If you make 360 degree minus 215, then what we get, the angle is we get this angle. This is the angle we get, 360 degree minus 215. So that means we get this angle, but that is not the included angle. Included angle is not only this much, it is also including this 15 degree also. So you need to add 15 degree here. So which means 360 degree minus 215 degree plus 15 degree, which will give you the answer for the included angle. So that is 160 degree. So 160 degree is given. So we'll select the answer as 160 degree. So therefore, you write the picture and just analyze in the picture only and directly find the answers. Try to find the answers in the included angles problems or in the bearing problems. Here is the next problem. In an old map, a line was drawn to a magnetic bearing of 10 degree 30 minutes, the magnetic declination being 2 degree east at that time. The magnetic bearing to which the line should be set now if the present magnetic declination is 4 degree 30 minutes west. See, now there is two conditions. The old map with that condition and now the new thing what we are doing at the present condition. In the present condition some scenario and the old condition is some scenario is given. Now what they are asking is you need to find what is the magnetic bearing of that line at present. So they are asking us to find magnetic bearing at present. So what we know, so in order to find this, it's very easy to do. Just draw the figure. Understand the first part. Magnetic bearing is 10 degree 30 minutes and the magnetic declination is 2 degree east. So which means, so let us draw that magnetic declination problem it is. Now assume that this is true north, okay, and we will take the magnetic bearing in different color. So this is our magnetic north, okay. And why I have taken the magnetic north to the right side, because they have mentioned is 2 degree east. So the declination, what is this 2 degree east means? It is nothing but a declination. So the declination means what? The angle between true north and the magnetic north. So therefore, and at that with that 2 degree east declination, they measured some line. That measured line length is 10 degree 30 minutes. So now I will take a line with a black color, and the bearing is measured. Okay. So assume that this is the line AB, and the bearing is, see, because you are using compass, so all the bearings whatever we measured is magnetic bearing. Whatever the bearing we get is through magnetic north, therefore it is magnetic bearing. So this magnetic bearing measured is given as 30 degree 10 minutes. So what will be the true bearing? True bearing is something which never changes. Say true north is the line which is fixed, and the bearing calculation, if you calculate the true bearing is never going to change over a period of time. So magnetic bearing will change because of the instrument, depends on the instrument, but and also depends on the time. So there is one more factor which will come due to time duration. Also there may be declination, changes in the declination. So true bearing is the value 1 which will never change. So the true bearing here is measured with respect to true north, that is 12 degree 30 minutes. You add just 2 degree plus 10 degree 30 minutes, you will get true bearing as 12 degree 30 minutes. Now this true bearing will never change. If it is old, if it is new, currently you are doing, it doesn't matter. So therefore, so our true bearing remains same. That is, so we have again we present condition, we have true north, and now present condition, the condition is given as they are having a declination 4 degree 30 minutes west. Now the magnetic north has shifted from east to west. So now this is magnetic north. Now this angle they have mentioned as 4 degree 30 minutes. Now they are asking us to find the magnetic bearing of this. But what we know the true bearing from the previous case. So true bearing is, just I will draw the line. AB line in this. So this is our AB line. We know what is the true bearing of this line. So true bearing of this line is 12 degree 30 minutes. How we get? We got it from the previous condition. So now they are asking us to find what is the magnetic bearing in the present condition. So the magnetic bearing, just by looking into this figure only, we can say the magnetic bearing is nothing but the bearing which is measured with respect to magnetic north. So that means we need to calculate this bearing from the magnetic north. So that is how we will get, add 4 degree 30 minutes plus 12 degree 30 minutes, we will get the total magnetic bearing for this. So just it is very simple, 4 degree 30 minutes plus 12 degree 30 minutes, which will give you the magnetic bearing for the present condition, that is around 17 degree. So answer is A, which means 17 degree. So if you add 12 degree 30 minutes plus 4 degree 30 minutes, we get 17 degrees. See, remember in this, the point to be remembered is, see, we have two types of bearings. One is called as true bearing. So what is true bearing? True bearing means the bearing measured with respect to true north. And this true bearing is never going to change over a period of time, fixed. We have another bearing we call as magnetic bearing. Most of the times, whenever we do surveying, whatever the bearings we get, they are in magnetic bearings. What is magnetic bearing now? The bearing which is measured with respect to the magnetic north. When, how will you get the magnetic north? Depending on the instrument. The magnet which is, it also depends on the magnetic power which is present in the magnetic needle of the compass. So the magnetic needle will deviate, some of the compass will deviate, some of them will show actually the correct one. So therefore, so the bearing which is measured with respect to the magnetic north is called magnetic bearing, which always changes. It always changes, it depends on the instrument. Whereas true north or the true bearing never changes, it is fixed. So just remember these two things. And if they give declination, if the declination is towards east, then just draw that declination magnetic north. See, declination means what? The angle between the magnetic north and the true north. The angle between the magnetic north and the true north. That is the declination. Simple. So you get true north now. Two norths. One is true north, another one is magnetic north. Draw the both lines and accordingly you solve the problem. So this is the best way of solving, drawing the picture, and you can just, no need to even take the calculator, just by observing these figures only we can give the answers to this type of questions. Yeah, moving on to next, leveling. In this we are interested in finding, see, four things what we majorly look in our surveying. Those are distance and angles. In the distance we have two things importantly we look. One is horizontal distance, second one is vertical distance. And in angles also horizontal angle and vertical angle. In order to get horizontal distance we use chains and tapes. In order to get the horizontal angle, of course, we use compass and theodolites. Whereas in order to get the vertical distance, we use levelings. The levels are the one which will give us the vertical heights or the vertical distance. So that is what we are interested in, finding the levels. So normally what we do in leveling is we take the readings from the instrument station, keeping the leveling staff at certain place. Normally, whenever we take the first reading observed from the instrument station is called as backside, represented with BS. And the last reading taken from the instrument is called as foreside. And the standard definition says whenever we are recording any first station, that is the first observation, that is backside, then the benchmark of that point should be known. If we are taking the first reading, that is the backside, keeping it in on the benchmark known RL. If we are taking the backside on the known RL, so if you want to take the backside, then the station point will be on the known RL. Whereas in foresight, it is an unknown place. In an unknown point, we will be keeping the leveling staff. So we are interested, wherever we are interested in interested to know the levels, reduced levels of that point may be termed as foresight. Sometimes it may be intermediate points. If you have some intermediate stations or where you will keep leveling staff and you record the reading, then we can call it as IS, intermediate sites. So basically, this is what we look in technically. These are the two uh, important things which we have to know. And of course, there are different methods to find the levels. So that is in order to find the reduced levels, we have height of the instrument method, and height of the instrument is method is also sometimes called as collimation method. Okay, and the second method is rise and fall method, and these are the two methods which we normally use. And most of the time the questions asked in these leveling chapter are uh, finding the levels or finding the corrections for curvature and refraction, and one more is we call reciprocal leveling. So let us concentrate. First we'll discuss the theory part and then we'll move on to problems with respect to this. The correction for curvature means, because already earlier only we have already discussed the surface of the earth is it's not flat, it's having curvature. So the curvature correction needs to be done in such cases. So always the curvature correction will be negative. See this, if we have an instrument, this is our instrument which will be showing our line of collimation. Because our earth is having curvature, the actual level of the line is in this pink color line. So the pink color line is the one which is the actual level, but instrument will be giving us the horizontal level due to this horizontal line. So there is some error, the error which is we are recording higher value than the actual one. So that means the required value whatever we are getting is more than the actual one. Therefore the correction is always negative for the curvature. So that will be given by say there is a derivation for this, but please remember this equation, the formula. If they ask us to find the correction for curvature, so you need to know this number 0.07849 d square, where d will be substituting the value of d is distance in terms of kilometers. Okay, and the next one is refraction. So what is this refraction? See, due to the bad light, due to the humidity in the place, what happens? There will be obstruction in observing the readings on the leveling staff using the dumpy levels, using the levels instruments. So that is called refraction. Refraction is due to the visibility of that instrument, of that leveling staff from the instrument place. So that will be always, see, if the instrument is showing you wrong, means if you're not able to see through the telescope, which means the error, of course the correction which we need to record is, we will not record the correct proper reading. So the reading whatever we'll record is it may be, normally it will be lesser than the actual one. Okay, so because of the problem of the visibility in that area. So therefore the correction in refraction is always positive and is given by this equation 0.01121. And we have two corrections now, curvature correction, refraction correction. And if we club both of this, then we'll get combined correction. The combined correction is given by this equation, that is 0.0673 d square, or it will be approximately equal to 6 by 7 times of curvature correction. CC stands for curvature correction, CR stands for refraction correction, capital C stands for both combined correction for the both curvature and refraction. So these are some of the uh, equations you have to remember in order to find the corrections if they ask on curvature and refraction. And coming to next, reciprocal leveling. In the reciprocal leveling, what we are interested is, see, we have a river here, and we are not able to take the readings in between this, because the water which is present here, which will not which will be not possible for us to take the points location there, and we cannot find the actual levels at these stations. So therefore, what we will do is, we need to carry out the reduced levels from one bank to another bank. So we will be placing our instruments on either side of the bank. So the first procedure is, we'll set up the instrument at near A, and we will record two readings. So from the first setup, we will record two readings. That is, we will keep the staff near to A, that is HA, and we will also keep the staff at B, and we record HB. So this HA and HP are the readings which are recorded from the station one, instrument station A. And we also shift the instrument to the other side of the bank, and we record two readings here also. So the two readings whatever we record here, you can name it as HA dash and HP dash. Now if you look into these two conditions, for the first condition, HA is very near to the instruments. See, HA is very near to the instrument means this value will be correct. This value, the value which is recorded near to the instrument, will be having no errors. Which reading will be having error? HB will be having error. Why? Because we just now discussed curvature effect. So when you have a length, say normally in the setting up of this instrument, so in the setting up of this instrument, we follow certain rules. Okay, that is, see, if we have 2 points we have located, the distance between these 2 points should not be more than 100 meters. So if you want to make sure this should not be more than 100 meter means we have to establish our instrument 50 meters to the first point to the left side of the instrument and another 50 meters. So this is called balancing. So if you place the selection of the or the position of your instrument of dumpy level in such a way that you have to balance on either side, it should be exactly at the center, then only we can eliminate this type of errors. It is not possible most of the time. In this case, especially in this case, assume that river having width more than 100 meter means, of course you will be ending up with curvature effect. So that 100 meters is the liberty which is given for the curvature line, and the horizontal line will bisect to a certain length. That length is 100 meter. So up to 100 meters, no need to worry. If you are having the distance between the 2 points is more than 100 meters from that instrument, then we need to apply the curvature and reflection correction. Therefore, whenever you are observing the readings which are more than 100 meters, that value will be having some correction needs to be applied to certain values, such values which are observed from the far end. So B is the far end for the instrument placed at A is the far end for the instrument which is placed at B. Therefore, HB dash, and here HB dash will be correct because instrument is placed very near to the station B. Therefore, the values observed at HB dash will be correct, but the values observed at HA dash needs to be uh, applied some correction. So therefore, so what will be the question they will ask is, they will ask us to find what is the difference in height between A and B. So we are interested in finding what is the true difference in elevation or the true difference in vertical distance between the A and B. So that will be given by HA minus HB. These are the readings observed from the instrument placed near A, and HA dash minus HB. These are the two readings which are observed from the by placing the instrument at B and making the average. See, we have to balance. No, we have to take the balance. So therefore, we will be taking the average. That is 1/2 times the difference of values observed from instrument A and the instrument B. This will give us the actual difference in elevation between the respective points. So there will be problem on this type of reciprocal leveling. So we'll see some of the problems in leveling work. Here is a problem. The RL of the point A is on the floor, which is 100 meter, and the backside reading on A is 2.455 meters. If the foresight reading on the point B, which is on the ceiling, is 2.745 meter, then calculate what is the RL of point B. So just picturize this so that our work will become very easier. So that is, see, we need to find the RL of B, and there are some conditions are given. The RL of the point A is 100 meters, which means point A is here on the floor, and the RL of this is 100 meters. And the backside reading at A, backside reading means I already told you backside is a reading which is taken on a known RL. Now, backside is taken at A, and for that A, we already know what is the benchmark or the RL of that point, and we have the instrument, and assume that we have this instrument here placed, and this instrument we are taking the backside. So this backside is equal to 2.455 meters from the floor level. From the floor level means from the point A. And we have another observation which is made, which is on the point B, and the condition is it is at the ceiling. So if you have ceiling or if you have a lintel, assume that this is the building and you are keeping that leveling staff to this some ceiling here. So you will be holding the leveling staff inverted. So whenever you are holding the leveling staff inverted, so we'll record that in a negative sign. So this is the foresight. This is the foresight observed. So to this point B, which is the ceiling, the observed reading is 2.745. So zero end of the staff will be kept here. So this is the height which will be equal to 2.745. Okay. So what they are asking is they are asking us to find just what is the RL. So if you just see here the picture, no need to know different formulas or nothing is required. You know RL of A 100. In order to come to this, in order to come to the uh, height of the instrument level, that is line of collimation level, add, because you are moving upward. So 100 plus how much we need to add? 2.45. So the line of collimation is 102.455 meters. So in order to get the RL of point B, what we have to do? We have to again move upward, because the point B is at the elevated position. So 102.455 plus 2.745. So if you add, we get 105.20 meters. So they are asking us to find what is the RL of point B. So point RL of point B is 105.2. So that is option D is the answer. So option D is the correct answer. So 105.2. So normally whenever we are having the staff held at the ceilings, that means the staff will be held inverted. Whenever this observed reading is inverted, we will record that in the level book in the with the sign negative sign 2.745. Remember this. Whenever you're keeping the leveling stuff, normally we'll write it, we don't use the plus sign, but we write it, this is 2.455 is taken when the leveling staff was held normally, whereas this 2.745 is at the ceiling, means at the ceiling we cannot hold on the top of the ceiling. We are finding the height for the ceiling, means we will be holding it as inverted. So whenever we are holding the staff inverted, we have to use the negative sign for the such type of uh, inverted holding staff positions. The next is a level was set up at a point A and the distance to the staff station B was 100 meters. Then what is the net combined correction due to curvature and the refraction as applied to the staff reading? So we already just saw that. See the combined correction. The combined correction will be given by 0.0673 d square, where d will be in terms of kilometers. So we need to substitute this 100 meters in terms of kilometers. That is, uh, we need to convert that into uh, kilometers from meters. 0.0673. So from meter to kilometer, that is, we need to do, that is 100 divided by that is 1000, correct? So that means it will be, you can say 1 by 10, 1 by 10 square d square. So therefore on calculation, after calculating this will be equal to 0.0673 meters. See, we substitute d in kilometers, but we get combined correction in terms of meters. Please remember this. For both, for the correction for curvature also, we substitute d in kilometers, but we get the correction in meters. Similarly, for the refraction, we need to substitute d. D is what? D is nothing but the distance between the 2 points from the instrument to the place where the leveling staff is held. That is d, distance, horizontal distance. So that distance will be given. So from using that, we will be finding out curvature correction and the refraction correction. But in this problem, they have asked combined correction. So therefore, we have used this particular equation to find the curvature correction, which is 0.0673, which means, so the answer is A. 0.00, I think you get 0.00673. So option is A. So they have given negative also here. So this is error. If they ask you to find what is the, instead of correction here, what is the error, then it will be negative, minus 0.00673. Because they are asking correction, it will be positive sign. Combined correction is always positive. And next one is a problem on reciprocal leveling. We have 2 points having some 1530 meters, and they are given the observed reading. So instrument is at A, 2 readings were observed, one is at A, another one is at B. So we can call this as HA and we can call this as HB. And again, second time instrument is at B, this reading we can call it as HA dash, and this reading we can call it as HB dash. So these 4 readings are given. They are asking us to find what is the true difference. So therefore, the true difference is, we can calculate using our equation HA, that is HA minus HB plus HA dash minus HB dash divided by 2. So what is HA? This is HA, this is HA dash, and this is HB, and this is HB dash. So we are using this HA dash and HB dash for the readings recorded from station B. So substitute those values. So normally this will be difference, whichever may be the higher value. So take the difference of that. From the higher value, deduct the lesser value, we will get the actual answer for this. So for this problem, it is 3.810 minus 2.165 is from the station A, and 2.355 minus 0.910 whole divided by 2. So on solving, we'll get H as 1.545. So on solving this, we get H is equal to 1.545. So this is the difference in elevation between the 2 points. So we have C, answer for this question is 1.545 meters. Now they are asking us to find the true difference. They may ask us to find even the error. What is the error due to this collimation? What is the error? So I will just show you how to find the error. In order to find the error here for the collimation adjustment, see, if you know error, then only we can make the adjustment. So for finding the error is very easy. So you take the difference of HA minus HB, instead of adding, see, we are having, see, we will add between those 2 points in order to get the difference in elevation. You just change that sign from adding to just deduct it, minus, then you will get the error. What is the error? So error HA dash minus HB dash divided by 2. So if you substitute these values, we get error is 0.1 meter. So now this error needs to be applied to which observation? Because from the station A, you are keeping near to the station A, so this value is not having any errors. It is free from any errors. Similarly, station B and the observed reading is from the instrument is at B and observed at B. This is also free from error. So you need to apply this correction, the error whatever we got 0.1 meters, we need to apply that for the far end of the station, that is for this reading, for this and for this reading. Okay, that is this will be, you need to you need to deduct, you need to deduct in order to get the correct staff reading. How much we need to deduct? We need to deduct, the error is positive, so correction is should be -1. So we need to deduct 0.1 meters from the observed value. That is 3.81 minus 0.1, which is 3.710. Actually, actual reading at station B is 3.710, but recorded is 3.81. Similarly, for this 0.1, you need to deduct 0.91 minus 0.1. So that will be 0.81 will be the correct reading for the station B. So this is to calculate the error. Okay. And next we have curves. So there we have two types of curves. One is horizontal curve, another one is a vertical curve. And in the vertical curve we have two types, where we have summit curve and a valley curve. And in horizontal curves we can classify that into two types, circular curve and a transition curve. In circular curve we have simple curve, compound curve, reverse curve. What is simple curve? Simple curve means having one radius. Compound curve means having two radius to form a curve. Reverse curve means it will be in the form of S, where the center of this curve will be on opposite directions. That is called reverse curve. And in transition curve, where the purpose of uh, going for transition curve is for smooth deviation. In these three types, simple curve, compound curve and reverse curve, there will be sudden deviation. When you are traveling, we should not feel the change in direction. Therefore, we go for transition curve. These transition curves are used for making the smooth deviation with respect to the roads or with respect to the railway alignments. So normally that is what we use. Uh, so we'll see one question on this, and we'll just finish up. And this is a problem. Not most of the questions are asked in the curves. Only one or two, hardly two. One question is asked. So one of the type of question they ask is, you have a two straight lines deviating with an angle of 60 degrees, and the radius of the curve is 600 meter. Then find what is the length of the chord and the mid ordinates. See this length of the chord and the length of the mid ordinates. So there are formulas which because of the time duration I'm not touching up those, are not listed this year, but it is commonly known for us. So the length of the chord is given by 2r times sine theta by 2. See, we know theta, the angle is 60 degree, and r is 600. You substitute, we get the answer for length of the chord. So 2 into 600 multiplied by sine theta. Theta is 60 degree. So if you substitute, we get length of the chord as 600. Okay, 600 meters. So 600 meter is here. So there are no other options which is starting with 600, means you can directly select B. Otherwise, if you want to calculate mid ordinate also, you can calculate it. The formula for calculating mid ordinate is given by R into 1 minus cos theta by 2. So you know theta, you know radius, so substitute 600 here, theta is 60 degree, calculate, we get 80.4 meters as the mid ordinate. So therefore the answer for this question is, answer is B. So this is on curves, normally they ask, or otherwise they will ask a question on transition curve, when you will be going for transition curve. And what is Sumit curve? Sumit curve means when you have a curve which is like a U, which is like a inverse U. I will show you. See, this is called summit curve, and this one is called valley. So valley means two hill station where joining together, where normally this is where the river will flow. So this is a valley curve, and this one is the Sumit Kar. We have some design part in that, and so we have only simple question which will be asked on the curves, and so I will stop at this stage, and will some of the additional problems I listed because of the time duration. Just skip these things, and yes, we'll end up this section on geometric surveying. See, for civil engineers, there is no such thing. There is no such a little mistake. You can see here, one side bridge is coming here, another side here. If you both of the points are not meeting together, then you will end up with this type of a blunder. So this is a mistake which happens. So thank you everyone for your active participation. Thank you everyone. Over to Arjun sir.
Thank you, sir. Thank you for the very informative session. From the Department of Civil Engineering and on my personal behalf, I thank Professor Anjan B K for uh, speaking about the geomatics engineering. Tomorrow's session will be on hydrology by Professor Madhushri and on mathematics by Dr. N. Bhaskar. Stay tuned for the remaining. Thank you.